So let's begin from where we stopped. So we were discussing about memory systems. So we were just made an introduction about memory systems and the addressing everything like that. So where I stopped is from there. So as we said, if an byte addressable system generated 32-bit address, so the 32-bit among the 32-bit, the first high order 30-bit will determine the word. Okay, the which word should be accessed, that is determined by the first 30-bit. Okay, out of the 32-bit, the first 30-bit will determine the which word should be accessed. So as I told, word is totally dependent upon the number of bits that a system can retrieve or stored actually can be accessed on a memory cycle. So a word can have multiple bytes. So that remaining 2 bits will decide which byte location should be involved. Like I will explain this in a small square. So let this is a word, and so this is a word, and the word size will be 32. Okay, so word size of this is 32, and this is 8 and 8. So let this is an there is 4 bytes in this whole word. So the first 30 bit, the first 30 will address this word. Okay, the first 30 bit will address this word, and the remaining 2 byte will address which of the byte should among this word. Okay, the remaining 2 bit partitive address is which of the byte among this 4 or maybe 2 or 2 bytes, depends. Okay, so which of the internal byte of this word should be accessed, whether it is should be accessed this or this. So it is actually described by the last 2 bits, and the whole word address is determined by the first 30 bits. So this is what happening here. So I just as I am removing this all. Okay, so let's back to topic. So this is what we explained here. So in a read operation, what happens is all the byte of the memory has been accessed, and only the one which is needed is selected. The another bytes has been fetched even, but it is being ignored. So in a read operation, even the other bytes of the word is being accessed. The only the exact one is one byte, I mean exact byte has been used, other one is ignored. So in the write operation, what happens is the control circuit, there will be a control circuit. So the control circuit will make sure that the content of that byte is only changed. Like we just made a mistake. So let this is the word, and the control circuit, if you want to change, if I want to suppose make sure okay, so if I want to make sure of change, I want to write on this byte, the control circuit will make sure that only the content of this byte is been changed. Okay, the control circuit will will make assure, it will make assure that only this byte of this whole word, this is a word. Okay, only this this byte of this word has been accessed and changed, making sure that all this and this word, I mean remaining words, has been untouched. Okay, so the data on the remaining word will be preserved. Only the only write operation, the byte that we are to be changed, or we are focusing on, we are targeting, it will be changed, or what we call rewrite, or what we call it is. Okay, so that is what okay, so in a modern computer, as we know, implementation of both complex to understand. We will discuss it later, how it's been implemented. So actually in modern computer, computing the computers we use, or even the supercomputers, as we know, there is lot of supercomputers. So in such supercomputers, it is hard to understand how it has been implemented, or how it actually like implemented there. So the initially we have to go with the traditional architecture, then only we can understand the advanced variant. So we will go with the traditional architecture. So this is a traditional architecture. I think everyone will be aware of this architecture. This is the traditional one. We used to do in our initial modules. So as there will be MAR, MBR, this is the processor side, and there is memory. So MAR is basically memory address register, and MDR is a memory data register. So there will be a K bit of address bus and N bit of data bus. So there will be a control line for read write operation, memory function complete, that is MFC signal. It's a acknowledgement actually sent in case of a completion of a memory operation, whether it is read or write. It's a acknowledgement is sent to the processor unit, like okay, the memory operation is being completed, you can proceed next. So that is a control this is like where the control signals has been passes. This is MDR, which means memory data register and memory address register. So we'll look what happens. The data transfer between memory and processor takes place through the use of two processor register, as we know, MAR and MDR. Usually it is called as MAR and MDR, as the theory suggests. The MAR is K bit long and MDR is N bit, as been discussing. So if MAR is K bit, we can address up to 2 raised to K address location, as we told in our early lectures. The 32-bit machine can register up to 2 raised to 34 which GB memory locations. That is the same concept coming here. If the MAR is K bit, then can address up to 2 raised to K address locations, and that's all. If the MDR is N bit, then the word length will be N bit. That is the another thing. So this is regarding to the word length. So word length is depending on the processor. I mean data bus. I mean that is a system dependency. Okay, so that is the two thing. If the MAR is K long, then and MDR is N bit long. This can and are integer variables. Okay, just make sure that. So during a memory cycle, N bit of data is transferred between the memory and processor. So as we know, the word length of data is been transformed. So during a memory operation or a memory cycle, at a single memory cycle, N bit of data is been transferred. That is the word length of data is been transferred. It can be reader or write, so it can be okay. So the transfer takes place over so how it takes, that's already we discussed. So again I'm telling how to is implemented right here. Transfer takes over okay. We have K address space and database lines, so we have to use both of that, and we also use you need to utilize the control lines. So the processor read data from the memory by loading the address required to memory address location and the MAR register and setting up a read write line to 1. That means explain. So if suppose memory need to address a specific location, let it be let me clear this all. Okay, so let the memory need to access location called 1001. So what happens is this data is being loaded to MAR register. Okay, so this data will be loaded to MAR register, and what happens is MAR register, after there will be a read comma write in the control signal. So that is what specifies. There will be a read write setup and to read write line, that is read write line is control line actually, and we will put it to 1. Okay, so if we put an address here like 1001 in MAR and we put read write line into 1, what happens is the processor will go for the memory and fetch this is the content of let it is the content on the address 1001, and the memory will the processor will fetch that address, I mean that data or that content, and go back here, and the data will be stored in MDR register. Okay, so MDR register will hold the data. Okay, so here we will apply the address where we want to fetch that data, and the MAR will send a request like making the read by write control to 1, and that data is being accessed by using the address given here, and that content from that address is copied to MDR register. That is happening here. So that is what here. Then the memory responds by placing the data from the addressing location on data line. As we know, this is data line, that with n bit data lines, as we know, depends on the word belt, that is we discussed earlier, and data confirm action. So as we know, once the memory function is completed, whether it can be a memory read or a memory write, anything it be, there will be acknowledgement, that is MFC, memory function complete signal. So the MFC signal will be initiated. So once the MFC signal is received, the processor can understand, okay, when the memory function is completed. So the upon acknowledgement of MFC signal, processor load the data into MDR register. So if the MFC signal is received, okay, the work is done, the data will be now on MDR register. So this is the whole thing. For writing the data, it is also simple, data into memory. The address where the data should be written is loaded to MAR, and the data is MDR. So in writing the in the case of writing, we have two parameters. Okay, as we using programming, so just turn down mixing that. Okay, as we discussed on writing data. So suppose I want to write the data into memory. So this is the memory unit. I want to write some data into memory. I need to pass two parameters. So first parameter will be the address, okay, where the data should be saved. Okay, that one be address. I know the spelling and the language is very bad, please. And the second thing is the data itself. So I need to pass two things. One is data and the second one is address. So how it pass is, I will put the address part, okay, the where the data should be stored. That is the first one, MAR register. Okay, memory address register will hold the address part where the data should be, where the data should be stored, that the address of the data. Okay, and data, this is the actual one I am going to show. Like suppose I need to store A, this is the data A and B, right? Actually it will be in binary form, so I don't want to make it more complex. I am already going in so much complex, I think, so I don't want to make it more complex. So is AB, I want to save this data, so I can't just send AB to memory. The memory can't decide where the data should be saved. So this is the address actual location of them on the memory. This is the location on the memory where data is to be saved. So this is 1001. It's actually in binary, or even the data will be in binary. I don't it doesn't care about that. Okay, so I had to pass two parameters, the data and the data location, I mean address. So I will put this 1001, that is the address of the data to be saved. So where the data is be saved, that is the address, that is will be in the MAR register, and the data itself, data where will be stored, MDR register. We have MDR, memory data register, that is the MDR register. We will store that data in the MDR register. So this is what happening. MAR register will have the data part, address part, and MDR will be the data part. So two parameters, okay, fine. And what we'll do, we will make the read bar write, that is control part, and we'll put the control part to 0. Okay, don't put 1 here. 1 will be what will happen, 1 if we initiate 1, the control will initiate a read operation. Okay, and it will go for the 1001 location, and it will fetch the data and replace the MDR register with that data. Okay, if we put R bar W bar read bar write line to 0, what happens is the data on the MDR register will be stored where the MAR is projecting. Okay, where MAR is projecting, that place will be rewritten by the MDR. Okay, that will be happen, and only when the MFC signal, here too there will be MFC signal. MFC signal is acknowledged. Okay, MFC signal acknowledged, that means the data in the MDR register is gone for MAR, or gone for the memory where the MAR is pointing out. So this is what happens here. Okay, So I think in the read write operation involve consecutive answers, we can go for block transfer operation. Just we have to go for the initial location. Block transfer actually means we can move for blocks actually. We do not need to address continuous segments. That is what block transfer. Okay, memory access can be synchronized using a clock, or it can be using a clock control signal, which is known as CS. I think most of design there will be a CS signal. That means we will discuss it later. So that's all. Memory access can be controlled using, I mean, synchronized using a clock, or it can be controlled using a clock signal. Okay, that's all. The memory read and write operation are controlled using an input and output bus transfer respectively. So as you know, input and output bus. For input, input the data. So write to data we use input, and to read the data will be output, right? That's all. So I think we are gone. We are explaining much more, and we will discuss in later videos. Thank you. Jai Hind. Okay, so okay, thank you.